Alright, let us do some more examples here. What I want to do here is, first, I want to do this example. Find f prime of x if fx equals to natural log of 9x. What is fx? Fx is given as natural log of 9x. So it is, if it was just natural log of x, the answer would be 1 over x. But there is 9x. Basically, this is u, right? So what is the derivative of u? So let's find out the f prime of x. That will be 1 over u times u prime. What is 1 over u? 1 over 9x times. What is the derivative of 9x? Just 9, right? So you cancel 9 and 9. Divide 9 is just 1. So it is 1 over x is the final answer. Okay? Basically, 1 over x is the final answer. By the way, this should be x to the 5. Okay? So y is given as x cubed times natural log of root under x to the 5. Okay? So how do I simplify this? I can simplify this as x to the third times natural log of x to the 5 half, right? I want to write using exponent in the exponent form. Now, because I can pull this exponent out to the front, right? So this can be written as x cubed times 5 over 2 natural log of x. See the formula number 3? That formula that I used, the property number 3. But this 5 half, you can pull that to the front. 5 half and then x cubed times natural log of x. Now I want to find out y prime. This is like, you can think this as like f, this is like g. So this is just a constant, you can pull that a constant out, right? So how do you write that? Is 5 half is there. Now, so how much is this? This is the f times g, right? What is the derivative of f times g? It is f prime times g plus f times g prime, right? F prime is 3x squared times g is natural log of x plus f times g prime, right? X cubed times, what is g prime? 1 over x. Let's simplify that. This is 5 half, right? 3x squared times natural log of x plus this x cubed over x, right? You cancel one of those. So what do you get? You cancel that with the cube. So what is left is x squared, right? So what is left is basically x squared. X squared. So the final answer is 5 over half. Let me pull that x squared out too. 3 natural log of x plus 1. That is the final answer. Okay. How about this? The last example on this page is find y prime if y equals to the natural log of x squared times root under 1 minus x. Let us simplify this. So here, before I found the derivative, before I differentiate, here I differentiate, right? Before I do that, I simplified and then write in the simple form. I want to do the same thing here. Okay, how do I do that? Basically, what I want to do here is y is given as natural log of x squared times root under 1 minus x. Can we simplify this? I want to use the property number 1. If there is a product, I can simplify this. I can write in the sum form, right? So I want to write natural log of x squared plus natural log of 1 minus x to the 1 half. That's what I want to do. Okay, so this can be written as 2 natural log of x. You have seen all this kind of simplification in college algebra, right? And then plus 1 half natural log of 1 minus x. Now I want to find the derivative. So let's differentiate on both sides. If you differentiate, what do you get? This can be written as y prime is equals to 2. What is the derivative of natural log of x? 1 over x plus, since this is a number, I can pull that out and find the derivative of natural log of x only. Similarly here, 1 half is pulled out. It is like the derivative of, this is like u, right? So what is the derivative of natural log of u? So it will be 1 over u times u prime. You see that? So it will be 2 times 1 is 2 over x plus 1 half times 1 over u is 1 minus x, right? Times, what is u prime? This is basically u. What is the u prime is 0 minus 1, right? So that will be negative 1. So the final answer look like 2 over x minus, because 2 times 1 times 1 times negative 1 is negative 1 over 2 times 1 minus x. That is the final answer for this example. Okay, so we'll see a couple more examples in the next slide or next page. Okay, let us look at this example, because so logarithm makes the problem very easy to find out the derivative. Okay, sometimes if you have to use the quotient rule or the product rule for the complicated type of problem, then you can use the log, you can take log on both sides. For example, look at this. If you have to use the quotient rule, it has a root and then quotient inside, right? So it will be complicated. But if you take a log on both sides, it will be easy problem. Let's take a log, okay? So let us do that, this problem. So it will be take log, okay? Take natural log, ln on both sides. Both sides. What do you get? You will get natural log of y is equals to natural log of root under 1 plus x square over 1 minus x. I took natural log on both sides to make this easy to find the derivative. I have not found the derivative yet. I want to simplify this first, okay? So this is basically, you can write natural log of 1 plus x square over 1 minus x square and then to the 1/2, because the root means to the 1/2. But in the log, that 1/2, that exponent goes to the front, right? So this can be written as natural log of y equals to 1/2 natural log 1 plus x square divided by 1 minus x, not x square. This is 1 minus x, okay? This is just 1 minus x. Okay, now, but in this quotient, I can break this into 1/2 natural log of 1 plus x square, right? Let's write on bracket there, minus natural log of 1 minus x. Now it is easy to find out the derivative of this thing, right? Because the derivative of natural log is just 1 over u times u prime. Natural log of u is 1 over u times u prime. So let's find out the derivative. Differentiate. What do you get? What is the derivative of that? You can write natural d ln y over dx, right? Equals to the derivative of these things. You can write 1/2, and then if you want to, you can write d and then ln 1 plus x square over dx, right? And then minus d ln 1 minus x over dx. I just wrote that step. You can basically skip this step, okay? Now look at this. They don't match, right? There is y, there is x. Similarly, here is natural log of, this is like a u, right? And similarly, here is, this is like a u. Natural log of u over dx. Let's write on v, because I don't want to use same u there. So v, this is v, okay? Let's find out the derivative there. So what do you get? You get basically 1, this is 1 over y times the y prime, right? That is basically because you want to find out y prime. So that's the y prime. So you'll have to multiply by y on both sides. So 1 over 2, what is that? 1 over u times the u prime minus 1 over v times the v prime, right? Because the natural log of v, the derivative of natural log of v, here is the derivative of natural log of u. And they don't match. There is u, there is x. There is v, there is x. They don't match. That's why we use that formula, right? So how much is that? 1/2. What is 1 over u is? 1 over 1 plus x squared times, what is u prime? The derivative of 1 plus x squared is just 2x, right? Because 0 plus 2x minus 1 over 1 minus x times, what is the derivative of 1 minus x is negative 1, right? Because 0 minus 1, negative 1. So let us write down that form. So how much would that be? Let me multiply by both sides by y as well. I want to multiply both sides by y as well, because and then simplify that, because I want to solve for that, will cancel out, right? So basically you get y prime equals to 1/2, right? That will be 2x over 1 plus x squared, and then plus, because negative 1 times positive 1 is negative 1 times negative 1 is positive 1, divided by 1 minus x. And let me plug in the value of y as well. Y was root under 1 plus x squared over 1 minus x. This is the final answer, okay? So that is the basically final answer.